Hi everyone. In this video, I will be going over the compositions of functions and inverses solutions. So let's just start right away. So section 1 basically set to find f of g and g of f. So let's do number 1 and figure that out. So f of x is 2x plus 1, and g of x is x minus 5. So if I wanted f of g, okay, what this means is I do f, and as the argument, I take g, okay? And what is g? It's simply x minus 5. So it becomes f of x minus 5. All I literally did was I just took the value of g, or the expression for g, which is x minus 5. Then what I do is my argument for f is now x minus 5. So literally what I do is I just plug it in right there for that x. So what it becomes is equal to 2, because that's the 2 over there. But instead of x, what I'm going to write is x minus 5, right? And the plus 1 comes from there. So now all I have to do is just solve that, or just, I guess, simplify it rather. So it's 2x minus 10 plus 1, and that's equal to 2x minus 9. So that's the expression for f of g. Now let's do the same thing for g of f. So g of f of x, it just basically means you get g, and as its argument, you put f of x. So I'm just going to put my equal signs here because I just need some room. My f of x is 2x plus 1, so 2x plus 1. And now all I'm doing is I'm taking my argument right here, and I'm just going to plug it in right for that x, okay? So here's what I'll do is instead of that x, I'll put whatever's in the argument and then minus 5. So what's in the argument is simply 2x plus 1. So this becomes 2x plus 1 minus 5, which is 2x minus 4, and that's our solution for g of f. So this is f of g, which is 2x minus 9, and g of f is 2x minus 4. Let's go on to number 2. Number 2 is f of x is equal to 3x minus 4, and g of x is 4 minus x. So if I want f of g, it's f, I take the argument, in my argument g, so this is f of 4 minus x, because that's what g is, and then once again, here's my argument. I literally plug it right into there, and that becomes 3, 4 minus x, minus 4. That's where this 3 is. This x is replaced with the argument, and the minus 4 comes there. So it's 12 minus 3x minus 4, which is equal to 8 minus 3x. And that's what f of g is. Let's do g of f now. G of f, right? So it's g of f of x. I'm just going to write it here. So it's g of 3x minus 4. This argument goes right into that x over there. And that's really it. All you're doing is just substituting your x for whatever argument you have. So 4 minus, and put it in brackets because this is really, really helpful, minus 4. So you get 4 minus 3x plus 4, which ends up being negative 3x plus 8. And that's your solution for this one. And if you observe, these two actually end up being the same thing, which is kind of interesting. So let's go to the next one. So number 3. All right, so f of x is equal to 2x minus 4, and g of x is actually equal to x squared. No, sorry, it's negative 3x. Sorry, I was skipping ahead. Negative 3x plus 9. So f of g of x is f, you take the argument of g, it's f of negative 3x plus 9, and you're just going to replace this argument with the x. In other words, that goes right there, and so it becomes 2, right, minus 4, and what's in here is simply negative 3x plus 9. It becomes negative 6x plus 18 minus 4, which is negative 6x plus 14. And that's that. Let's do the opposite. G of f of x, and this is g of f of x. The argument of f of x is simply 2x minus 4, so g of 2x minus 4. You simply take this and you substitute in right there, okay? And that equals negative 3, 2x minus 4 plus 9. So that becomes negative 6x plus 12 plus 9. And that is simply negative 6x. Let me just double check this. Make sure you always put brackets for whatever value you have of x. So that way, if there's a negative, you can multiply it out and make sure that you have the correct sign. So this will equal to plus 21. So this is, yeah, this looks fine. Yeah, perfect. So that's negative 6x. So that's g of f. All right, let's do number 4. Number 4 is, okay, so here's where it starts to get interesting, where we have the square roots and all that good stuff. So it's square root of x plus 2, and g of x is equal to x squared. So here we have f of g of x, so it's f of g of x, and g of x is simply x squared, so it's f of x squared. And remember, all we're doing is we're just taking this argument and plugging it right there. Okay, that's all we're doing. It's nothing fancy in any way. So this square root stays, right? And that plus 2 stays as well, but instead of x, we're going to replace it with x squared. So x squared. And really, this cannot be simplified. This cannot be simplified any further, so we're done over here. Let's do the opposite. G of f of x. So this is equal to g of, you take in as the argument f of x, so it's g of square root of x plus 2. And remember, all this means is you take this and then you sub it in for x. That's all you're doing. So this equals something squared, and that something inside is simply the square root of x plus 2. And let me see. So that is equal to x plus 2, because the square root and the square sort of cancel out, so you're left with x plus 2. So this is the solution for g of f, and this is the solution for, maybe I should just write this, x squared plus 2. This is the solution for f of g. Number 5. Number 5 is f of x is equal to x minus 3. G of x is equal to x squared plus 5. Okay, so f of g is f of g of x. So f of x squared plus 5, right, because that's what g of x is. And you take this, literally, you just take this and you're subbing in right for x. That's all you're doing. So basically, it's going to be something minus 3, and that something is x squared plus 5, and that's simply equal to x squared plus 2. And you're done. G of f of x is, I'll just write that equal here, so g of f of x, so that's g of, it's x minus 3, because that's what f of x is. And literally all you're doing, as always, is you're taking this value, this argument, and you're plugging it right into that x over there. So it's simply equal to something squared plus 5, and it's just going to be x minus 3, because that's the argument right here. And you can leave this alone if you want. If you want to expand it, that's fine too. Okay, you know what? I'll just expand it for the sake of expansion. But if we expand it, you can leave it like here. I would give you full marks at this point. But if you expand it, is x squared minus 6x plus 9 plus 5, because the expansion of this is simply that, and that's equal to x squared minus 6x plus 14, and that's our solution right there. Number 6, I believe the last one was 5. Yeah, last one was 5, so number 6. Oops, am I skipping something? Sorry, I just little. Oh, here we go. All right. So now we're going to do number 6. Number 6. So, all right. So f of x is equal to 2x plus 1 square rooted, and g of x is equal to x plus 1 squared minus 2. So let's do f of g. So f of g of x is equal to f of g of x, and g of x is simply that, so it's f of x plus 1 squared minus 2, okay? What I'm going to do is I'm just going to expand this, it'll make my life a little easier. So it's going to be x squared plus 2x plus 1 minus 2, and if I simplify that, it's f of x squared plus 2x minus 1. And now all we're doing is we're taking this argument right here and we're plugging it right into that x over there. And so if we want to do that, we just go down a bit further. So it's going to be the square root of 2 something, and let me just go back, see what the function is. Right, plus 1. So the something inside is simply x squared plus 2x minus 1. So if I want to expand this a little bit, just make it a little easier. So to simplify it, 2x squared plus 4x minus 2 plus 1. And this will come out to simply 2x squared plus 4x minus 1. All right, so that's my solution for f of g. Let's do g of f. Let's do g of f, right? So it's equal to g of f of x, and f of x is that expression there. So it's the square root of 2x plus 1. And remember, all we're doing is we're taking this argument here and plugging it right into that x over there. So this is simply equal to something plus 1 squared minus 2, and that something is the square root of 2x plus 1. I'm not going to expand it because when you expand this term, we'll end up with a square root. So I normally wouldn't give a question like this. I just wanted to show you how this would work. So this would be sufficient. If you left it like that, that would be sufficient. Number 7, f of x is equal to 2x plus 1, and g of x is equal to the square root of 3x minus 4. 3x minus 4. So let's do f of g of x, and that's f of, that's what it means. So g of x is, so it's f of whatever's that is, so 3x minus 4. And remember, all we're doing is we're taking this, plugging it right into that x over there. So that's equal to 2 times something plus 1, and that something is 3x minus 4. And you can just leave it like that because you can't really simplify that anymore. Let's do g of f of x, and that is equal to, I'll just do it here. So it's g of f of x, and f of x is 2x plus 1, so it's g of 2x plus 1. And remember, all we're doing is we're taking this argument here, plugging it right into that x over there. And that's simply equal to the square root of 3 of something minus 4, and that something happens to be 2x plus 1. This can be simplified a little bit further, so let's just do that. Always try to simplify if you can. So 6x plus 3 minus 4, which is equal to the square root of 6x minus 1, and that's our solution right there. Okay, so that was number 7. Let's go to number 8. Number 8. Okay, so f of x is equal to 4x minus 1, and g of x is equal to 2x squared plus 3. So f of g of x is equal to f of g of x, and what that is equal to is f of 2x squared plus 3, so 2x squared plus 3. And remember, all we're doing is we're taking this argument and subbing it right there. Okay, so it's equal to 4 of something minus 1, and that something happens to be 2x squared plus 3. So we can simplify this. This is 8x squared plus 12 minus 1, which is equal to 8x squared plus 11. And that is f of g. All right, let's do g of f. G of f of x. So that's g of f of x. So that's equal to g of 4x minus 1. 4x minus 1. And remember, all we're doing is taking this argument and subbing it right into that x over there. So it's going to be 2 of something squared plus 3, and that something happens to be 4x minus 1. We can expand this, and actually, I will expand this. So this is, if I expand this one, this is 16x squared minus 8x plus 1 plus 3, and that's equal to 32x squared minus 16x plus 2 plus 3, which is 32x squared minus 16x plus 5. And that's our solution for g of x, g of f of x. All right, so last two, let's go to number 9. Number 9 says f of x is 5x squared plus 1, and g of x is equal to the square root of 3x minus 1. Now, if you want f of g of x, it's f of g of x, and what are we going to sub in for g of x? It's going to be f of the square root of 3x minus 1. And what we're doing is we're taking this argument and subbing it right into that x over there. Okay? So this is going to equal to 5 something squared plus 1. That something happens to be this argument. So 3x minus 1. And if we simplify, this is simply 5 times 3x minus 1. The square root and the square sort of cancel each other out. And if I simplify, I get 15x minus 5 plus 1, which is 15x minus 4. And that's my solution for f of g. Let's do g of f now. So g of f of x is basically the same idea. So g of f of x is equal to g of square root of, oh, sorry, it's not the square root now, it's I'm doing f. So here we go. So g of 5x squared plus 1, because that's what f of x is. It's simply 5x squared plus 1. And all I'm doing right now is I'm taking this argument and I'm substituting it right there into that x. So it becomes the square root of 3 of something minus 1, and that something happens to be 5x squared plus 1. So that's equal to, oops, I need to go scroll down a bit. So it's equal to the square root, and so this becomes 15x squared plus 3 minus 1 and becomes 15x squared plus 2. And that's our solution. All right, let's do the very last one for this section. So number 10. So here we have f of x is equal to 3x plus 1 squared plus 2. And here I have g of x is equal to the square root of 4x plus 3. So let's do this. So in other words, f of g of x is equal to f of g of x. So g of x is that expression there. So the square root of 4x plus 3. All we're doing, as always, you take this argument and you sub in right in for that x. Okay? And so this equals 3. And it's going to be something plus 1 squared plus 2. What is that something? It's simply the square root of 4x plus 3. Okay. Now, like I said before, if you square a square root, it just ends up being a square root. And I would not normally give a question like this, so we can just leave it like that. Now, if we want g of f of x, this is going to be g of f of x. F of x is that expression there, so it's g of 3x plus 1 squared plus 2. I'm going to close the bracket there. And what I'm going to do is I'm actually going to simplify this expression a little bit. So it's going to be g of 3x squared plus 2x. It's lagging a little bit. Plus 1 plus 2. And I'm going to close it right there. And I'm still with the g. So g of, it's going to be 3x squared plus 6x. I'm just going to expand and simplify automatically. So it's 3 times 1, which is 3, and that plus 2 is 5. So it's going to be plus 5. Okay, we close it right there. Now, if you observe, what we're doing is we're taking this argument right here, and we're going to plug it right, let's hope I have space. We're going to take this expression, so we're going to take this argument right there, and we're going to plug it right into that over there. So it's going to end up being the square root. Is it 4x plus 3? Yes, it is 4x plus 3. So it's 4 times something plus 3. And that something just happens to be the argument. So it's 3x squared plus 6x plus 5. So it's equal to square root of 12x squared plus 24x. Now 4 times 5 is 20. And 20 plus 3 is 23, so I'm just going to write plus 23. And that's our solution for g of f of x. All right, so now we're done with the sort of the compositions of functions. I'm going to move on to section 2, which is finding the inverse. So let's do section 2. Okay, so section 2 says find domain and range of f of x. So let's do 1. So f of x is simply 2x minus 3. It really helps to draw it out. So 2x minus 3, so in other words, here's minus 3. We know it's going upward because the slope is upwards. So there we go. Right? So that's the equation, or that's the diagram. So domain is x is element of reals. It's just a straight line, so it goes over all the x's. And the range is y is element of reals. And there's no restrictions because it goes on forever. So maybe I'll just clarify by saying that it's this red line, this red arrow right here. That's the equation. So there's your f of x, and that's the domain and range. So let's find the inverse function. So the equation is y is equal to 2x minus 3. So the inverse must be where you switch the x and y. So you get that. And then you solve for y. So basically it becomes y is equal to x plus 3. X plus 3. And then you divide by 2. Divide by 2. So the inverse function, this is how you're supposed to properly write it, is x plus 3 divided by 2. This is our solution for part B. So this is, I guess, A. Part B starts here, I guess. This is the domain and range for A. This is part B. Now write the domain and range of f inverse. So as we know, if we have the domain and range of the function, they just reverse. But since they're both elements of real, the domain and range of this inverse function is also going to be the same. We don't even have to sketch it, but we will in the next question. So basically this is part C, and this is the domain and range of the inverse function. And finally, sketch both f of x and f inverse on the same graph. So I'm going to do this f inverse in green. So it's x plus 3 divided by 2. Really, if you think about that, that's simply half x plus 1.5. Because if you divide by 2 for each, 3 divided by 2 is 1.5, and this is really half x. So the inverse function would basically be plus 1.5, so that's somewhere over there, and half x would be a slightly shallower slope. It'll still be positive, and it's like that. And keep in mind, remember, there's both of those functions reflect. I shouldn't use red. Let me use yellow. Both of those functions reflect across this line, right? Remember, this line is y equals x. Right? So the red line and the green line, if I reflected them across this yellow line, which is y equals x, I should get basically each other. They should equal to each other. Or they should reflect, and that's how you get the other one. All right, so let's do number 2. Number 2. So number 2 is, it's very similar to number 1. It's equal to 3x plus 4. So the first one says get the domain and range. So the easiest way is just draw a little sketch. So it's plus, let me just use red. So it's plus 4 over here, and it's going upwards because of the 3. So it's going to be a straight line that goes this way. And so the domain and range is pretty straightforward. It covers everything. So the domain is x is element of reals, and the range is y is element of reals. So that's straightforward. That's A. B, find the inverse function. So first, just write this as y equals 3x plus 4. Next, switch the x and y. So x equals 3y plus 4. Then solve for y. So x minus 4 equals 3y. And then y is simply x minus 4 divided by 3. Or if I want to say another way, I could say it's like 1/3 x minus 4/3. So the inverse function is simply 1/3 x minus 4/3. All right, so that's how that goes. And if we want, okay, so then the domain and range of this one. So this is part B. Domain and range is, remember, we just switch them, but since they're both reals, so for part C, we're just going to do domain is x is also element of reals, because since y is element of reals, that's what the domain is. And the range is, since the domain of the function, of this function, is x is element of reals, the range will simply be y is element of reals. Just remember that the domain and range switch for the inverse function. And the last part says to sketch both of them. So since we have this equation right here, this is 1/3 x minus 4/3. So minus 4/3 will be, I don't know, somewhere over there. So minus 4/3. It's going to be a shallower slope. It's because it's 1/3 compared to 3x. So it's going to look something like this. And keep in mind that, so this red one is going to go like that. So keep in mind that all what happens is that it's just a reflection across this line, which is y equals x, right? And if I reflect, I see that I get the same. If you had a mirror at y equals x, the red line would reflect to the green line, and that's basically how you get each other. All right, so let's move on to number 3. Number 3 says, okay, so here's an interesting one. So number 3 says f of x is equal to negative 2x minus 4, and they're giving us the domain pretty much. They're saying x is greater than or equal to negative 2. So let's just see what that looks like. So let me just draw that. So let's just see what that looks like. So they're saying that x is greater than or equal to negative 2. So normally what this would look like is it would be facing down, and here's negative 4, and it would be going downwards. It'd be going downwards like that because of the negative 2. But now they're saying x is greater than or equal to negative 2. So we need to find the y-coordinate where it stops. So let's just find that out. So when f is negative 2, it means negative 2 times negative 2. So it's equal to 4 minus 4, which is 0. So in other words, it basically starts here. It basically starts here and just continues towards the right. So anything towards the left it does not count. So because that's the domain that we've been given. So it basically starts at x equals negative 2. So it starts at negative 2 right there, and just goes towards right as x increases. So what is our domain and range? Our domain and range is now, so the domain is x is element of reals, x is greater than or equal to negative 2. The range is y is element of reals, but we can see that the range decreases. So, and it starts from 0, as we saw over here. So y is less than or equal to 0. So that's the domain and range. So this is basically part A. Okay, now let's do part B, which is actually finding the inverse. So y equals negative 2x minus 4. So remember, the first thing you do is switch the x and y. So, all right. And let's solve for this. So this becomes x plus 4 equals negative 2y. I just added 4 on both sides. And then I'm just dividing by negative 2. So it's x plus 4 divided by negative 2. And if I want to simplify, this is just negative half x, because this is half x divided by negative 2 is just negative half x. And then positive 4 divided by negative 2 is minus 2. So f inverse, and remember, you have to finish up with writing f inverse. You can't just write y. It's negative half x minus 2. Okay, so that's part B. And now part C says find the domain and range of the inverse. So remember, if we have the domain and range of the function, we already have the domain and range of the inverse. So for the function, it's x is element of real. So the range of the function becomes the domain of the inverse. So in other words, this is x is element of reals, but now we say x is less than or equal to 0. And the range, so the domain of the function is the range of the inverse. Remember, because we're just switching the inputs and outputs. So this is y element of real, right? And since this is x is greater than negative 2, this is simply y is greater than or equal to negative 2. So let's see, now that we have our domain and range, let's just see how this sort of looks like. So we have our inverse function here, which is negative half x minus 2. So let's sort of graph that. And negative half is going to be a shallower slope than this negative 2 over here. So I'm going to use green, and it's going to be negative half x minus 2. And this is the y-intercept. So for the other equation, it was negative 4. So this is basically negative 2 right here. And it's going to be a shallower slope. So it's basically going to connect. It's not going to be the best of lines, but it's going to be something like that. But let's look at our domain and range. Our domain says x has to be less than 0. So we only have to take the x points that are less than 0. So in other words, we're going to sort of eliminate all of that right there. And hold on, let me just write the values down. So that's negative 2, and then I think I erased the negative 4 over there. So this is not 1, but this is negative 4, because that's the y-intercept of the red line. And if you observe, this says y is greater than negative 2. So the negative 2 is right here, and it's basically going up here, or it's actually sort of going down, but we're only going to consider the points that are above y is equal to negative 2 for the green line. So that's basically how you graph both of them on the same curve. And if you observe, this is basically kind of a reflection, right? Like this green line, which is sort of shallow, if you reflect it across the yellow line, which is y equals x, you will get that red line. And that's basically how that works. All right, let's move on to the next one. The next one says, the next one does not give a domain, but you're supposed to figure out what the domain is. So anyways, for f of x is equal to the square root of x plus 1. So let's see what this looks like. So as we know, right, from having graphed square root functions and quadratic functions, this means to the left 1, so this is -1, and it goes like that. So right away we have the domain and range. The domain is x's element of reals, and so this is part A. And then the range is, x's element of reals given that x is greater than or equal to -1. And for the range, y is element of reals. So it basically, the y starts from 0 and goes upwards, so y is greater than or equal to 0. So that's your domain and range. Now, part B says find the inverse. So first what we do is we just write y is equal to x plus 1. Then you just switch the x and y. So x equals y plus 1 square rooted. To get rid of the square root, what you have to do is just square both sides, right? Because we're trying to solve for y now. And what this is simply x squared is equal to y plus 1. And if you subtract, so y equals x squared minus 1. Now, so that's, I guess, and then the inverse function is x squared minus 1. Now, what I'm going to say is this is actually kind of incomplete, and we'll see why in a second. Oh, by the way, I should have just drawn this in red. I should have drawn this one in red, because we'll see, we want to compare this with its inverse. So now, so we have that. And I'll explain why this is incomplete in a second, but let's just do part C, which is the domain and range. So the domain and range, so this looks like a quadratic, so we might think that there's a parabola here, but it's not actually going to be that. But we'll see that in a second. So the domain, remember, this is the domain and range of the function, and we're trying to find the domain and range of the inverse. So the domain of the inverse is the range of the function. So this is x's element of real, and x is greater than or equal to 0. And the range is basically the domain of the function. So y is element of reals, and y is greater than or equal to -1. Now, let's just see how that looks like. So, so that's part C, where we have to graph everything. So let's sort of look at this function, x squared minus 1. What we know is that it looks like a parabola. So it would look like this. I'm not going to draw this part, and you'll see in a second why. But basically it would go like this and come up like that. So I'm just going to draw the right part, and you'll see why in a second, because it says, oh, and this is -1. This y-intercept value here is -1. So it says the domain is x is greater than 0. Well, here's where x is greater than 0, and we're just moving to the right. So I have that part. And it says y is greater than or -1. Well, y starts at -1 and moves up that way. So in other words, really what we have is half the parabola, because we've restricted the domain and range of the original function, we have to also restrict the domain and range of the inverse function. So remember how I said that this was incomplete? Well, it's incomplete because we're not taking the full parabola. We have to state the domain. So the domain here is x is greater than or equal to 0. So that's what would make this function complete. This is actually the correct inverse function. And once again, as I'm sure you'll notice, is that if I just draw this y equals x right there, right, and the red line and the green line will reflect across that y equals x, and that's how we know, that's how we can sort of graphically obtain the inverse. All right, so that's number 4. Let's move on to number 5. Number 5 will be f of x is equal to -5 square root of 3x plus 2. Okay, so as you can observe, there's a reflection across the x-axis, there are some stretches, and it's moved up too. So always sort of draw a graph. So this would, in this direction, would be the typical square root function, but there's a reflection across the x-axis, and then it's up 2. So in other words, it would basically start from here. The stretches really don't change the direction, right? They change the shape of it, but they don't change the direction. So basically it would go something like this. So this is our function. And let's get the domain and range. So the domain is x's element of reals, and x is greater than 0, because remember, it starts at 0 and just moves to the right. So x is greater than or equal to 0. And the range is it starts at 2 and goes downwards. So y is element of reals, and y is less than or equal to 2. So that's our domain and range, so that's part A. Now part B says find the inverse function. So y is equal to -5 square root of 3x plus 2. Okay, so then we switch the x and y, so it's -5, 3y plus 2. And since we're switching x and now we have to solve for y. So I'm going to subtract 2 from both sides, so it's x minus 2 is equal to -5 square root of 3y. Then I'm going to divide by -5, so x minus 2 divided by -5 is equal to square root of 3y. The next thing I'm going to do is I'm going to square both sides because I want to get rid of that square root. So I'm going to square that, and by doing so, I'm going to leave this in this sort of square form. So it's going to be x minus 2 divided by -5 squared, and it's going to be equal to 3y because the square root and the square cancel out. And then finally, what I'm going to do, actually, you know what? I'm going to sort of square this. I'm going to leave the numerator as is. So it's going to be x minus 2 squared. But then -5 squared is going to be 25. So that's equal to 3y. Then if you divide both sides by 3, if I divide this fraction by 3, the 25 and the 3 will multiply. So y is equal to x minus 2 squared divided by 75. So basically f inverse of x, that's a -1 by the way, is really 1 over 75 times x minus 2 squared. Okay, and this again looks like a quadratic, but as I've said before, this is not complete, and I'll show you why in a second. So let's do part C. Part C says find the domain and range of the inverse function. As we know, we just have to switch them. So I'm just going to do that. Scroll that a little bit down there. So if we switch them, the domain of the inverse is really the range of the function. So x is element of reals, and x is less than or equal to 2. The range is y is element of reals, and y is basically, remember, the range is equivalent to the domain of the function, so it's y is greater than or equal to 0. So we basically have a quadratic here. This is our inverse function. It's moved to the right by 2, and this is our stretch factor. We have a vertical stretch of 1 over 75. So it's moved to the right by 2, and there's no shift upwards. So basically it will be like this. Now, it's a parabola, right? It's a parabola, but let's keep in mind our domain and range. So our domain says it has to be less than 2. So if this is 2 right there, it has to be less than 2. So in other words, we're just going to focus on the left part, and y has to be greater than 0. So in other words, it's going to go like this. It's basically going to be something like this. Like that's how our parabola would be. That's not the best parabola. So really it would be something like this, but we're not going to take the right part because we only want the part where it's x is less than 2. So I'm just going to erase that. So we're going to erase it all the way here, all the way to there. So this green line is our inverse function, which is basically our parabola. And once again, as always, you will notice that it reflects across this line. So basically, if I took the red line and reflected across the yellow line, which is y equals x, I would get that green line, which is the inverse function. Okay, so that's how we graph the two. Let's move on to the next one. So that was number 5. Now we have number 6. Just use white again. So number 6, we have f of x is equal to -4 square root of 2x plus 6 plus 1. So it's equal to -4. So let's factor that out. So 2x plus 3 plus 1. And let's see how that looks like. So if we have that right there, what that really means is there's a reflection across the x-axis. So normally it would look like this, a reflection across there. We have a vertical stretch of 4, horizontal stretch of a half. But remember, the stretches don't really affect the shape. They affect the shape, but they don't affect the direction. And it's being moved 3 to the left. So that's -3, and then up 1. So it's going to be like that, and basically it's going to go down like that. So that's what this function looks like. Let's get its domain and range. The domain is x's element of reals, and x has to be greater than or equal to -3. The range is y's element of reals, and y has to be less than or equal to 1. So that's the domain and range of the original function of f of x. Now let's do part b, where we find the inverse. So here's our function. So basically y is equal to -4 square root of 2x plus 3 plus 1. So here we have that right there. Maybe I'll just use a different color. I'll use this color right here to separate that. Okay, so this is our function. So what we want to do is find the inverse. And in order to find the inverse, we have to switch x and y. So literally just switch x and y. So -4 square root of 2y plus 3 plus 1. And now we have to solve for y. So we subtract 1 from both sides. We get x minus 1 is -4 square root of 2y plus 3. Then we're going to divide by -4 on both sides. So x minus 1 divided by -4 is equal to the square root of 2y plus 3. Then if I want to get rid of the square root, I have to square both sides. So I'm going to square this side, and I'm going to square that side. And what I'm going to do is I'm going to... So if I square I'm not going to expand the top, I'm just going to leave it like that. So it's x minus 1 squared. But if I square the bottom, -4 squared is actually positive 16. Okay? And if this square root and that square cancel out, so I get 2y plus 3. Next thing I'm going to do is I'm going to divide by 2. So if I divide by 2 on both sides, basically if I divide this expression by 2, the 16 and the 2 will multiply. So we get x minus 1 squared over 32 is equal to y plus 3. And finally, if I want just y by itself, y is going to be x minus 1 squared divided by 32 minus 3, because I've subtracted it from both sides. And therefore, f inverse, that's f negative 1, is going to be 1 over 32 times x minus 1 squared minus 3. This is divided by 32, which is the same thing as saying 1 over 32. So really, this is my vertical stretch. We're moving it to the right by 1 and down 3. And this looks like a parabola right here. So let's... And this is not complete because, well, we'll see that in a second why. So here, let's go part C. Part C is find the domain and range of the inverse function. So the domain of the inverse function is the range of the inverse. So x is element of reals, and x is going to be less than 1. And the range is y is element of reals, and the range is the domain, or is equivalent to the range of the inverse is equivalent to the domain of the function. So since this is x is greater than -3, it's going to be y is greater than or equal to -3. And we saw over here that our inverse function is to the right 1 and down 3, and it's a parabola, right? So let's just see how that sort of comes out into play. So it's to the right 1, and down 3. So let me just extend this white line here a little bit. So it would probably be some... I'm not sure if it would... So... right. So right 1 and down 3. So I'm not sure if it would come across, but this is just a sketch. So it doesn't really matter. Yeah, it doesn't really matter. So let's just say that this is -3, And so this is our point right here. So that's 1, negative 3. And once again, I got that from here. This is 1 to the right, down negative 3. So it's 1 to the right here and down negative 3. Now, we would normally have a parabola that goes like this. We would normally have a parabola that goes like this. But let's look at our domain and range of the inverse function. It says x is less than 1. So if x is less than 1, it has to go this way. And so basically what our function would look like is it would probably look something like, it would look something probably most likely like this. It's not a very good parabola. Let me just try that again. It would probably look something like this. And normally it would continue this way, but remember, our domain of the inverse function says x less than 1 only, so we'd have to erase this part, right? And that's what our inverse function would look like. And once again, as always, you know, the best way is it has to reflect over this line, which is y equals x. And I'm sure you can see visually, if I reflect over that line, this red line would reflect to that green one over there. So that's how we do number 6. Oh, and why I said this one was incorrect is because this is not entirely true. We have a new domain for this. It's not the entire parabola. And as we said, this was x is less than 1. So really, we should have just completed this by saying x is less than or equal to 1. So that would be the proper way of defining this inverse function. Let's go to number 7. Number 7 is f of x is equal to x squared plus 1, and x is greater than or equal to 0. So let's see what that looks like. So here's my parabola, and it's moved up by 1. It's moved up by 1. So this would be my normal parabola, but it's shifted up by 1. So it's basically going to go like this, right? But I have this restriction. X has to be greater than 0, just so it's to the right. So what I have to do is I have to erase this part, right? And that's what my function really looks like. So if I want to get my domain and range, right? So a domain is x's element of reals, and x has to be greater than 0, right? Because x starts from here. So x is greater than or equal to 0, and that's what they pretty much told me right there. And the range has to be y's element of reals, and y starts at 1 and goes forward. So y has to be greater than or equal to 1. So all right, so that's your domain and range. Let's do b. Let's find the inverse function. So y is equal to x squared plus 1. So switch the x and y. So x is equal to y squared plus 1. Solve for y. So x minus 1 is equal to y squared. And then if I have to solve for y is equal to the square root of x minus 1. Now you have to be a little bit careful, because really what we should say is we should say plus or minus. But keep in mind that we have our domain and range over here. So I'll leave this plus and minus for now, and then I'll change it in a second. So let's do part C, and then that will help us determine how to do that. So part C says if you want the domain and range, remember they switch. So oh, sorry, I forgot. So f inverse of x is plus or minus the square root of x minus 1, and we'll just change this in a second. So remember, the domain of the function is the range of the inverse, and the range of the function is the domain of the inverse. So x is element of reals, and x is greater than or equal to 1. The range is y's element of reals, and y is greater than or equal to 0, because remember, the range of the inverse is basically the domain of the function. So let's see how this looks like graphically, and then we'll just change this part. So this says that x has to be greater. So this looks like a square root function. We don't know whether it'll go up like that or it'll be a reflection depending on the plus or minus. But we can see that x is greater than 1. So if x is here, x is greater than 1. X is greater than 1 and y is greater than 0. So if that's the case, it has to only be like this, right? And this looks like a positive square root function. So what we're going to do is pretty much just change this, and instead of the plus or minus, now we know for sure that it is the positive square root function, so this is plus. So this is the correct answer. It's very important to know whether it's the plus or minus square root function. And that's what the inverse function looks like, that green equation over there. And once again, remember that it will reflect across this line, y equals x. And if I reflect the red line over that y equals x, I will get that green line, as you can see over there. All right, 3 more questions, and then we should be done. Oh, let me use white. Let me use white. So 8 is f of x is equal to x plus 2 squared minus 4, and I'm given my domain, which is x is less than or equal to negative 2. All right, so here's my function, here's my domain. Let's graph this. So as I can see, it means 2 to the left and then down 4. And there's no reflection. 2 to the left and then down 4. So it's like that. So normally I would have it as it's going down there and then something like that. But we're told that our domain is x is less than 2. So we have to erase this part. We have to erase all that. We have to erase all that. Okay. So that's our point, and I'm just going to draw these axes again so it's nice and clean. Let's draw that straighter. Okay, so this is our function. Its coordinates are -2, -4, and it goes up this way. All right, so let's get the domain and range of this function. Let's do it here. So, oh, there we go. So the domain is x is element of reals, and x is less than or equal to -2. And the range is y is element of reals, and y is greater than or equal to -4. So that's part A. That's the domain and range of the original function. Let's do part B, which is the inverse. So y is equal to x plus 2 squared minus 4. So if we want to find the inverse, switch x and y. X is equal to y plus 2 squared minus 4. And then we have to solve for y. So we have to add 4 first. So x plus 4 is equal to y plus 2 squared. Then what we want to do is get rid of the squared. So what we do is we square root both sides. We square root both sides. And once again, I'm just going to put plus or minus here because we need to determine whether it's going up or going down. And we'll see that in a second. So what that equals is plus or minus the square root of x plus 4. And it's equal to y plus 2. And let's solve for this. So y is equal to, if I subtract the -2, so it's going to be plus or minus square root of x plus 4 minus 2. Okay? And our inverse function, therefore, is going to be plus or minus square root of x plus 4 minus 2. Now recall that we can't have both. We can't have a plus or minus. It's just one of them. But we're going to find the domain and range of this function and then determine whether it's supposed to be plus or minus. So let's do that. So now we're on to part C. So part C says the domain is the range of the function. So in other words, x is element of reals, and x is going to be greater than or equal to -4. And the range, on the other hand, is going to be the domain of the function. So y is element of reals, and y is going to be less than or equal to -2. So let's take a look at it graphically and see how that works. So really what it means is the x and y switch. So for example, this point right here, which is -2, -4, would become, okay, 1 second, I just need to extend this a little bit, would become -4 on the x, and, sorry, 1 second, -4 on the x, and -2 on the y. So -4 on the x, so it would be something like this. So -4 on the x and -2 on the y. So this point right here would translate to over there. And let's look at our domain and range. Our domain and range basically say, and that also makes sense over here. It's like, if you look at x plus 4, that means 4 to the left. It's 4 to the left, and it's down 2, and it's down 2, so that's why we get that point there. Now we have to ask ourselves, is it going to go like this, like that, like this, or like that? And so we'll see that in a second. It says x is greater than -4. So in other words, it's either going to be this way or that way, right? And we can see that it's either going to be straight up or straight down. And it says y has to be less than -2. So in other words, y has to go like this. So basically, it will go like that. And if it's going to go like that, and we just got that from the range, right? So if it's going to go like that, it means that it's a reflection down. So this has to be negative. So this value right here will be negative. And it's negative, I'll explain why one more time. The reason why it's negative is because it's going downwards. So if it's going downwards, it's no longer going upwards. If it was upwards, that would be positive. If it's downwards, there's a reflection. So that's why it's going over there. And once again, if you observe, if I draw the line y equals x, the red line would basically reflect over and become the green line. All right, so it's very important to use that as sort of a comparison whether one reflects over another. That was number 8, so let's do the last two, which is number 9 and number 10. So number 9. Number 9 is f of x is equal to -3 x minus 4 squared plus 1, and x is greater than or equal to 4. Okay, so we have that. So let's just take a look at what that looks like. I'm going to draw that out there. Stand that out there. Okay, so this means that there's a reflection, so it's going to go down. It's going to be downward facing. We move it to the right 4 and up 1. So, and there's a stretch of 3, so it's going to be like relatively thin. Or actually, I'm going to use red. So I have 4 because it's to the right 4, and then it's up 1. So it's going to be there, and it's going to look like this. But keep in mind, we said x is greater than 4, so we're going to have to erase the left part. And that's basically what it's going to look like. Let me just get the white back and draw that line. So it's going to go like that. Okay, so that's what it's going to look like because of our domain over there. So let's get the domain and range of this function. So the domain, so this is part A, the domain of this function is x's element of reals, where x is greater than or equal to 4. And we already know that because that was given in the question. And the range is y is element of reals. Now y has to be less than 1. It's 1 and it's decreasing, so y has to be less than or equal to 1. So that's your domain and range of this function. Part B is we've got to find the inverse. So y is equal to -3 x minus 4 squared plus 1. Then we have to switch the x and y. So x is equal to -3 y minus 4 squared plus 1. We subtract 1 from both sides. So x minus 1 is equal to -3 y minus 4 squared. Then you divide by -3 rather. So x minus 1 divided by -3 is equal to y minus 4 squared. So what we're going to do now is we're actually going to square root both sides because I need to get rid of that 2 over there, or rather the square term. So if I square both sides, basically, let me see here, it's the white again, there we go. So this is going to be, oh, and keep in mind, I'm going to keep this as plus or minus because we have to determine whether it's going to be plus or minus. So, and we'll do that in a second, determine whether it's plus or minus. So this is going to be plus or minus square root, and you can factor out the -1/3. So it's just the -1/3 x minus 1. They just mean the same thing, right? This is just a fraction here, and I can just take out that fraction, it's x minus 1, is equal to y minus 4. Now, if I add 4 to both sides, y basically becomes plus or minus the square root of negative 1/3 x minus 1 plus 4. I've just basically added 4 to both sides. And the last thing I have to do is you must write it in this way. So it's f negative 1, which is basically f inverse, plus or minus square root of negative 1/3 x minus 1 plus 4. We'll now talk about where we're going to do something here and determine whether it's the plus or the minus that we have to, what it is. So let's look at the domain and range of the inverse. So this is part C. So remember, the domain of the function is the range of the inverse, and the range of the function is the domain of the inverse. So this is x element of reals. So this is going to be x is less than or equal to 1, and the range is y's element of reals, and it's the domain of the function, so it's going to be y is greater than or equal to 4. So since this is a square root function, we can observe that we know for sure there's a reflection across the y-axis. We don't know if there's a reflection across the x, but we know that it's moved to the right 1 and up 4. So let's just basically do that. So we move to the right 1 and up 4. So that's 4 over there, right? We know that there's a reflection this way, but we don't know if it's in the y-axis, but we don't know if it's there or if it's reflected even further down. So let's see how that would work. We know that the domain of our function is x is less than 1, so we know that it's going to be this way and definitely not this way, so it's going to be this way. Now let's look at the range. The range says it has to be greater than 4. So if it's greater than 4, that must mean it has to go up that way, right? And so that is our range. So we know that there's no second reflection, because if there was a reflection across the x, it would go down this way. So let's correct our function. So this function has to be positive. It has to be positive. So this one will be positive. And once again, the reason why it's positive is we can see that there's a reflection across the y, which is the reason why it looks like this. Instead of looking like that, it looks like this. Now, if there was a second reflection, it would go further down. But keep in mind that our range was that y is greater than 4. So there is no second reflection. There is no reflection across the x-axis. So since there's no reflection across the x-axis, that's why this is positive. That's why that remains positive. And once again, I'm going to state is that if you observe the green and the red line, they kind of look like reflections across this line, y equals x. If I take the red and I reflect it across the green, or reflect it across the yellow line, I will get the green line. All right, so that was number 9. And now, finally, the last question. Let's do number 10. Number 10 is f of x is equal to 2x minus 3 squared minus 4. X is less than or equal to 3. So here's our function. This is our domain. Let's just see what that looks like. So there's our function. So what this means is there's no reflection. There's a stretch of 2. It's to the right 3. So it's to the right 3. And it's down 4. So it's down 4. So, but it's facing up. But it's facing up. We have a stretch of 2. And since this is saying x is less than 3, it's not going to be a full parabola. It's simply going to be half the parabola right there. Maybe not the best diagram. So let me just do something like this. Okay, so normally it would go up like that, but because it said x is less than 3, we're not going to count that. We're just going to leave it like this. So there we go. So from this we can determine our domain and range. So our domain is x is element of reals, and x is basically less than 3, which we've been told that basically. The range is y is element of reals, and y is greater than or equal to -4. Right? Y is greater than or equal to -4. Now, part B says find the inverse function. So y is equal to 2x minus 3 squared minus 4. Switch x and y, so x equals 2, y minus 3 squared minus 4. So I'm going to add 4 to both sides. It becomes x plus 4 equals 2, y minus 3 squared. I'm going to divide both sides by 2. So it becomes x plus 4 divided by 2 is equal to y minus 3 squared. I want to get rid of that squared, so I'm going to square root both sides. Square root both sides. And I need some more room. So if I square root both sides, basically another way of, and oh, one more thing, as usual, I'm going to write plus or minus. And we're going to determine whether it's plus or minus in a second. So basically this will be plus or minus. And another way of writing this is just basically half times x plus 4. So I'm going to write half times x plus 4. The reason why I write it this way is so I know what the horizontal stretch will be. And this is equal to y minus 3 because the square root and the square cancel out. Finally, I just want y. So y is equal to plus or minus square root of half x plus 4. And this is going to be plus 3 because I'm adding 3 to both sides. So my final step is don't leave it as y, write it as f inverse. So f inverse of x is plus or minus square root of half x plus 4 plus 3. Now we're going to determine whether it's plus or minus, and because only one of them can fit. And then we'll do that in a second. But first what we need to do is we need to find out what the domain and range of the inverse function will be. So remember that the domain of the inverse function is the range of the original function. So this is basically x's element of reals, and x is greater than or equal to negative 4. And for the range, it's the range of the inverse function is the domain of the original function. So y is element of reals, and y is less than or equal to 3. Okay, so we have the domain and range of the inverse function. Let's graph that and see what that looks like. So we know that just looking at the inverse function, we know that it's going to be to the left 4 and up 3. But what we don't know, and there's no a reflection across the y-axis, but there might be a reflection across the x-axis. So let's sort of look, based on the domain and range, we'll determine whether this is plus or minus. So remember, left 4, up 3. So I'm going to use green. So left 4 and up 3. So I'm just going to say that's like there. So we know that's the point. And again, let's take a look at the function. This is either going to be a reflection across the x-axis or not. So either it's going to go this way or it's going to go down this way. And let's see how that looks like. So we know that x is going to be greater than or equal to negative 4. So it has to be this way or that way. And then if we look at the range says y is less than 3. So if it's less than 3, it has to go down this way. So in other words, it's going to go something like yeah, it's going to go something like this. So if it's going to go something like this, then so in other words, there's a reflection downwards. So we know right away that this has to be a minus. Okay. The reason why it's a minus is because let me just put white there. The reason why it has to be a minus. Okay. The reason why it has to be a minus is because there's a reflection downward. If it was positive, it would go up. But because there's a negative, or because we determined from our range that it has to be less than 3, so in other words, it has to be less than that, so it has to go down this way, and if it goes down this way, that implies that there's a reflection across the x-axis, and if there's a reflection across the x-axis, we have to make sure that's a negative. So that's a solution for f inverse. And one last thing just to recall is remember that these red and green lines reflect across y equals x. So if I got the red line and I reflected across the yellow line, I would get the green line. All right, so hopefully that made sense for inverses and composition of functions, and I'll see you in the next video.